Chapter 10. Minerals and Power Resources. Reading Objectives. Mineral Resources. Occurrence of minerals. Classification of minerals. Extraction of minerals. Distribution of minerals. Power resources. Distribution of power resources. Alternate resources of power. Mineral resources of India. Power resources of India. Mineral and power resources are important for the economic and industrial development of a nation. Their distribution on the Earth's surface is very uneven. The appearance or absence of mineral and power resources can have a powerful impact on the progress of a country. Mineral resources. Minerals are one of the most valuable natural resources. They play an important role in the development of human life. The mineral wealth of the country has a direct impact on the standard of living of the country. Minerals are said to be the second natural resources after plants and animals that were exploited by man. In fact, the various stages of human existence on the earth are identified with the minerals. We have early Stone Age, Middle Stone Age, Later Stone Age, Bronze Age, Copper Age, Iron Age, and now the Steel Age. All these ages are named after one or the other mineral. Thus, minerals have contributed greatly to the development of man from ancient and primitive times to the modern scientific age. Enrich yourself. Conservation of minerals and power resources. Minerals take a very long time to develop, and so they cannot be replenished immediately at the time of need. Continuous mining and wasteful use of minerals and power resources may lead to their exhaustion. Therefore, it is necessary to use them economically. The following steps are helpful in conserving minerals and power resources. Reduce wastage in the process of mining. Improvement in the techniques of extraction and purification. Recycling of metals in which the mineral resources can be conserved. Use of alternative energy resource. Occurrence of minerals. Minerals occur in different types of rocks. Some are found in igneous rocks, while others in metamorphic and sedimentary rocks. Minerals either occur in pure form, in veins, or may be mixed with materials. The mixed minerals are known as ore. Minerals may occur in the cracks, joints or crevices of rocks. The occurrences in small quantities are called veins, and in large quantities are called lodes. They usually occur in igneous and metamorphic rocks. Many of the major metallic minerals like tin, copper, silver, lead and zinc are found in veins and lodes. The minerals deposited in the form of layers in the rocks are called beds. Coal and some grades of iron ore are found in bed formation. Other minerals, like gypsum, potash salts and common salt are found in beds and seams. Bauxite, the ore of aluminum, is formed by the process of deep weathering of rocks. The weathering is caused due to heavy rainfall. Some minerals, like gold, tin and platinum, are resistant to weathering. The particles of these minerals get deposited within sand, clay and gravels from where they are extracted by placer or shaft mining methods. Classification of minerals. On the basis of the type of the mineral and its commercial importance, minerals are classified into two groups. Metallic. These include metal in a raw form. Non-metallic. These do not include in metal. Do you know? Graphite is sometimes called plumbago or black lead. It is never used as a fuel but used in pencil making. Crucibles and tires are also made of graphite. Metallic minerals. The metallic minerals are the most valuable minerals. Metallic minerals may be ferrous or non-ferrous. Ferrous minerals include iron, like manganese and chromite. Non-ferrous minerals do not include iron but include some other metal, like gold, silver and copper. All these are being used for a wide range of purposes. Non-metallic minerals. The minerals like mica, gypsum, limestone, salt, potash, nitrates and mineral fertilizer are non-metallic minerals. Sulfur is used in the chemical industry. Asbestos and certain precious stones, like diamonds, are also non-metallic minerals. The non-metallic minerals, like coal, petroleum and natural gas, are also used as fuel. Extraction of minerals. The early man used rocks for making hunting and cutting tools. The discovery and smelting of metals brought the Bronze Age when bronze was used by man. This, followed by the discovery of iron and Iron Age, was identified with the use of iron tools. The present age is called Material Age. Today's man is well aware of minerals and their use. Most of the extraction today is carried out through mining. Mining. The extraction of minerals is called mining. Since minerals occur in varied forms, different methods of mining are required for their extraction. These are follows: open cast mining. This cheapest and easiest method of mining is carried out for the minerals that lie near to the Earth's surface. For example, coal or iron ore. It involves the scooping and striping off of the mineral-bearing rock with the help of huge excavators and power. Limestone, gravels, igneous rocks and clay for bricks are also extracted by open cast method of mining. Underground mining. When the mineral deposits are located deep within the earth, mining is carried out. This is done by removing the overburden or waste by mechanical shovels. You might have seen shaft mining in films where miners go under a shaft, tunnel, in a lift. Tunnels are dug deep into the earth to reach the spots where minerals are found. Tunnels are exploded and broken into balls, and then taken up through another shaft to waiting trucks. This is the deepest form of underground mining. Coal, gold and copper are some minerals that are mined this way. Placer mining. Placer mining is used to get the minerals deposited in the alluvial or placer deposits of the river and stream beds. One such example is the gold-bearing sands. This process uses the gold's high density, that makes it sink, to break it from the lighter siliceous matter with which it is found. Distribution of minerals. Metallic and other valuable minerals are distributed unevenly over the surface of the earth. Some parts of the earth are rich in minerals whereas others are very poor. Some minerals are found only in restricted areas of the world. Ural of Russia and Canadian Shield have abundance of many kind of minerals. But Amazon Basin, Netherlands, Denmark, some parts of Central America are very poor in minerals. More than half of the world's tin comes from Malaysia, Thailand, China and Indonesia. USA has molybdenum, sulfur and phosphates in abundance. Canada dominates world in nickel production. 70% of world's gold, diamonds, cobalt and platinum are found in Africa. Iron. Iron does not occur in pure form. It occurs in ore form. There are three types of iron ores. Magnetite is the finest iron ore with a very high iron content up to 70%. It is a black ore formed in igneous or metamorphic rock veins and lodes. Hematite is the most important industrial iron ore. It has somewhat lower iron content than magnetite. Most hematites have 50 to 65% iron in them. The color of the ore is red and it comes from sedimentary rocks. The ore occurs in crystalline or powdery form. Limonite is a brown-colored iron ore. It is found in thick beds in the sedimentary rocks. It is also known as bog iron when it occurs in swamps. It has an iron content less than 50%. Vast quantities of iron ore are found in Russia, USA, Ukraine, France, India, Sweden and Germany. Copper. Copper has been in use since ancient times. It may be found in pure form, but it more often occurs in chemical combination with other elements in the veins of igneous rocks. It is widely used to make alloys, like bronze, brass, German silver, etc., by mixing it with other metals. Copper is also a good conductor of electricity. The leading copper producer of the world are Chile, USA, Peru, Mexico, Canada, Russia, Poland, Congo, Zambia, Australia, Indonesia and India. Bauxite. Bauxite is the main ore of aluminium. It contains aluminium in the form of hydrated oxide. Bauxite is found mainly in the tropical and subtropical areas. It is light in weight and good conductor of heat and electricity. Leading aluminium producers are Australia, Jamaica, Guinea, Suriname, Russia, Guyana, Hungary and USA. Bauxite is used to make railway coaches, aeroplane bodies, utensils, chemicals, transmission wires, scientific tools, building construction, pipes, boats, etc. Manganese. It is derived from two ores, pyrolusite and selenium by electrolytic methods. It is used to make alloys. The steel industry and textile industry are the two largest users of this metal. Russia produces 42% of the world's manganese. Other producers are South Africa, Gabon, Australia, and Brazil. India produces 8% of the world's total produce. China, Mexico and Ghana also produce some manganese. Gold. Gold occurs mainly in alluvial deposits. It is separated by placer mining methods. It is a precious metal used for making ornaments and other items of luxury. The greatest leading producer is South Africa with 70% production. India, Canada, Japan, USA, Papua New Guinea, Australia, Philippines, Zimbabwe and Ghana are other producers of gold. Silver. It is lustrous white metal. Its ore is argentite, though most of the silver occurs in free form, or in a mixed form with lead, copper, zinc and gold. The chief producers of silver are Mexico, Russia, Canada, USA, Peru, Australia, Poland, Japan, Chile and France. Diamond. It is commonly used to make jewelry. It can be also used for cutting glass and drilling hard rocks. South America, Africa, Australia and India are the producers of diamond. Mica. Mica is a non-conductor of electricity and it is largely used in the electrical goods industry. It can be split into very thin sheets. Paints, varnishes, medicines and lubricants are made from smaller blocks of mica. The leading producers are South America, India, Norway, Brazil, USA, etc. Distribution of power. Man has been using natural power resources since times immemorial. These were solar energy, wind and water energy. Then he discovered fossil fuels, like petroleum, natural gas and also coal deposits. Today the major fuels in use are coal, oil, gas, together with wood, peat and nuclear power. Distribution of power resources. The world depends on fossil fuels for its energy. Coal, petroleum and natural gas formed from the prehistoric matter of plants, animals and other life that was buried sometimes miles deep inside the earth and subjected to high temperatures and high pressure over millions of years. These resources include a wide assortment of carbon-based substances. Coal. Coal is the most abundant source of power. Its importance increased with the invention of steam engine in 1776. Afterwards, iron and steel industries depend upon coal. Today coal is used for generating electricity in the thermal power units. Based on its carbon content, coal is divided into following types. Anthracite is the hardest coal and rank highest amongst the coals. It is jet black in color and shining. It has a carbon content of about 95%. It burns for a long time and leaves very little ash behind. Lignite is a soft and brownish variety of coal. It has nearly 40% of carbon since it has a high moisture content, about 35%. It gives much smoke and little heat on burning. Bituminous is a hard, black and compact coal. It contains nearly 70% carbon and is the most common type, making up world's 80% coal output. Graphite. The carbon content of graphite is higher than anthracite coal, i.e. almost 99%. Graphite is sometimes called plumbago or black lead. It is never used as a fuel but used in pencil making. Crucible and tires are also made of graphite. Peat is a dark brown substance including partially decomposed vegetable matter. It is hard to burn as it emits little heat and a great deal of smoke. The leading coal producer of the world are China, USA, Germany, Russia, India, UK and Canada. Petroleum. Petroleum is found as crude oil trapped in between layers of sedimentary rocks. It is a black, greenish, or brown-colored liquid. It is the mineral that is in greatest demand in modern history. It is often referred to as black gold. It is drilled from onshore and offshore oil fields. Petroleum is a necessary source of energy for all internal combustion engines in automobiles, railways and aircraft. Today, three principal grades of crude oil are recognized. Paraffin base oil contains a high percentage of lighter hydrocarbons, like methane. It yields petrol, paraffin and high-grade lubricant oils. Asphalt base oil mainly contains heavier hydrocarbons with asphaltic base. It produces very little of petrol and yields asphalt and bitumen almost in solid state. Mixed base oil has mixed properties of lighter and heavier hydrocarbons. It has a high percentage of naphthalene. It is used for both lubricants and fuel oils. The leading producers of petroleum are Iran, Iraq, Saudi Arabia and Qatar. USA, Russia, Venezuela and Algeria also major petroleum producers. Natural gas. Natural gas may occur along with petroleum deposits. It may also occur alone. The gas is released when crude oil is drilled and brought out to the Earth's surface. Natural gas is used as domestic and industrial fuel. Natural gas fulfill about 20% of the total energy required in the commercial world. USA is the major producer of natural gas, accounting for 42% of the world's production. Other countries that supply natural gas are Russia, Netherlands, China and UK. Get to know more. Floating air. The air inside a hot air balloon is heated by a gas burner. The hot air is lighter than the cold air outside, so the balloon floats. Alternate resources of power. The increasing use of fossil fuels is causing to its shortage. If the current rate of consumption continues, these resources will get exhausted. Therefore, there is need for using alternate sources such as hydroelectricity, thermoelectricity, nuclear energy, wind energy and tidal energy. Hydroelectricity. It is produced by using the force of falling water. The water can fall naturally or can be made to fall by building dams across rivers' channels. The falling water is channelized to enter a turbine and the moving blades turn the generator to generate electricity. The water coming out of the turbine is used for irrigation. Thermal electricity. It is generating by burning fuels, like coal, petroleum or natural gas in specially designed furnace, called thermal generators. These power stations are located mainly at the places which have abundance of coal, natural gas, or petroleum. The greatest number of thermal power stations are located in industrial parts of Western Europe and northeastern North American, USA, Russia, Japan and West Germany. Nuclear energy. It is the modern world. The radioactive decay of uranium and thorium releases nuclear power. Nuclear power is the energy obtained either through fusion and fission. Through a very expensive program, atomic energy needs enrichment of uranium in specially designed atomic reactors. Only a few countries have the technology of producing atomic energy. India is one among them. Wind energy. It has tremendous potential for development. It is used for providing water and for generating electricity. It is safe, clean, and non-polluting source of energy. The main countries for producing this energy on large scale are Netherlands, Germany, Denmark, India, USA, UK, etc. Tidal energy. It is energy generated from tides by building dams at the openings of the sea. A turbine is installed in the dam to produce electricity. Russia, France, UK and India have the tidal farms. Mineral resources of India. India is one of the world's most naturally endowed lands. India is home of numerous minerals which benefit the country economically. The minerals produced in India constitute 1/4 of the world's most popular mineral resources. India is gifted with important mineral resources. The country produces about 89 minerals, out of which 52 are non-metallic, 4 are fuel minerals, 11 are metallic, and 22 are minor minerals. The metallic minerals include iron ore, copper ore, chromate and zinc, gold, manganese, bauxite, lead and silver. The non-metallic minerals include limestone, magnesite, dolomite, barytes, kaolin, gypsum, apatite, steatite and fluoride. Iron ore. Iron ore is abundantly available in the Earth's crust. It forms basic raw material for iron and steel industry. Hematite and magnetite are the most prominent of the iron ores found in India. The major deposits of iron ore located in Jharkhand, Orissa, Chhattisgarh and Goa states. Major hematite resources are located mainly in Jharkhand. Manganese ore. About 1/5 of the world's manganese deposits are in India, and India is the 5th largest manganese producer of the world. Madhya Pradesh, with 97% of India's manganese, is the leading producer in the country. Orissa, Karnataka, Maharashtra, Andhra Pradesh and Jharkhand also have deposits of manganese. Bauxite. Madhya Pradesh, Jharkhand, Gujarat, Maharashtra, Karnataka, Tamil Nadu, Goa and Uttar Pradesh are the states that produce bauxite ore in India. Copper. Jharkhand is the largest producer of copper ore. Rajasthan is the second in rank, followed by Uttaranchal, Andhra Pradesh, Tamil Nadu and Karnataka. Gold. Kolar and Hatti gold mines of Karnataka are the main suites of gold mines in India. Andhra Pradesh also has small quantities of gold. Mica. India is the largest producer of the mica in the world. Its huge deposits are found in Gaya, Munger and Hazaribagh districts of Jharkhand. Mica is also found in large quantities in Andhra Pradesh and Rajasthan. A large quantity of mica is exported to other countries. Gypsum. About 75% of India's total production of gypsum comes from Rajasthan's Bikaner, Jodhpur and Jaisalmer areas. It is also found in small quantities in Tamil Nadu, Andhra Pradesh, Uttar Pradesh and Gujarat. Searching dictionary. Mineral resources. Resources that are mined from the earth's crust such as iron ore, bauxite, copper, etc. Mining. The extraction of minerals from the earth's crust. Non-conventional resources. Those resources which we get from non-living beings. Ore. Any solid naturally occurring mineral, which has a large concentration of a particular mineral. Natural gas. A gaseous fossil fuel. Biomass. A renewable resources energy that is created from burning of wood, garbage and other previously living things that have stored the sun's energy. Coal. India has good reserve of coal. India's most important coal fields are Raniganj in West Bengal, Jharia, Giridih and Bokaro in Jharkhand. Lignite occurs in Neyveli in Tamil Nadu. Jharkhand has 37% of the country's coal reserves, followed by 18% in West Bengal and 16% in Madhya Pradesh. Petroleum. Petroleum is found in Digboi in Assam, Cambay, Ankleshwar and Kalol in Gujarat and Bombay high off the shore of Mumbai. The petroleum produced in India is not sufficient to meet our requirements. Petroleum refineries have been set up at many places in India. Power resources of India. Energy is consumed in a variety of forms in India. Fuel wood, animal waste and agriculture residue are traditional sources of energy that continue to meet the bulk of energy requirement in rural India. These non-commercial fuels such as petroleum, thermal power, hydroelectric power, wind power, nuclear power, natural gas and biogas. Thermal power. Thermal power is the major source of power in India. Coal, diesel and natural gas are used for generation of electricity. Thermal power constitutes about 65% of the total electricity generated in India. The thermal power generation is being supervised by the National Thermal Power Corporation, NTPC, which was established in 1975. NTPC today has to its credit 13 coal-based super thermal power projects with 19,480 megawatts capacity. It has 7 gas or liquid fuel-based combined cycle projects with 3,955 megawatts capacity and 3 joint venture projects with 314 megawatts capacity. These figures stand as on the 31st of March 2005. This makes the total thermal power of 82% of the total capacity in India. Get to know more. Movement energy. Things that move very fast, such as the wind, have a lot of energy. A wind turbine has propeller-like blades that turn in the wind. The turning blades drive a generator that produces electricity. Hydroelectric power. The first power plant installed was a hydroelectric project at Darjeeling in 1897. In 1902, second such plant was installed at Sivasamundram waterfall of Kaveri River in Karnataka. This was followed by the power plants at the Western Ghats, Uttar Pradesh, Himachal in North India and Tamil Nadu in South in 1930. Up to 1947, the total hydroelectric capacity reached 508 megawatts. With the creation of National Hydroelectric Power Corporation, NHPC, in 1975, massive efforts were made towards developments of hydroelectric projects in the country. At the end of 2005, the hydroelectric generation capacity will be gained over the next decade. Till now 19% of this target stands achieved and another 8.7% is about to be achieved. Wind power. The wind power potential of India is about 45,000 megawatts, out of which capacity of 8,748 megawatts has been installed in India till the 31st of March 2008. India is one of the leading countries in generating the power through wind energy. Gujarat, Andhra Pradesh, Karnataka, Madhya Pradesh and Rajasthan are states having more than 500 megawatts potential each. These potentials could be improved if the technology of putting turbines in sea is embraced. There are wind farms on sea generating high as 160 megawatts of power. Nuclear power. The Tata Atomic Energy Commission was incorporated in 1948 soon after independence. The work on nuclear power program was started with the establishment of Atomic Energy Institute at Trombay in 1954. This institute was renamed in 1967 as Bhabha Atomic Research Center, BARC. The first nuclear power station was installed at Tarapur near Mumbai in 1969. Today we have the Tarapur station with 320 megawatts, Rawatbhata near Kota with 300 megawatts, Kalpakkam in Tamil Nadu with 440 megawatts. Other nuclear installations are at Narora in UP, Kaiga in Karnataka and Kakrapara in Gujarat. In all, India has 6 nuclear power stations with a total power generation capacity of 2,590 megawatts in 2002-03. Natural gas. In India, the Gas Authority of India Limited, GAIL, was set up in 1984 as public sector undertaking to locate new reserves and to transport and market natural gas. Reserves of natural gas have been located on the eastern coast near the Krishna-Godavari Delta. Natural gas is also found in Tripura, Jaisalmer and offshore wells near Kandla in Gujarat and Mumbai in Maharashtra. Biogas. Biomass is converted into gas through a gasified after combustion. The biomass could be used to generate steam or power or can be used as a fuel. There are various examples of gasified power plants in India. Power is generated using rice husk in Andhra Pradesh, while several biogas-based plants are there. India has a potential of 3,500 megawatts from biogas. Other fast-growing plants could be planned over a huge area, so that it provides biomass for generating power. Word to know: the appearance or absence of mineral and power resources can have a powerful impact on the progress of a country. Minerals occur in different types of rocks. Some are found in igneous rocks, while others in metamorphic and sedimentary rocks. On the basis of the type of the mineral and its commercial importance, minerals are classified into 2 groups, metallic and non-metallic. The extraction of minerals is called mining. There are three methods of mining: open cast mining, underground mining, and placer mining. Some parts of the earth are rich in minerals whereas others are very poor. Some minerals are found only in restricted areas of the world. Today the major fuels in use are coal, gas together with wood, peat and nuclear power. India produces 89 minerals, out of which 52 are non-metallic, 4 are fuel minerals, 11 are metallic, and 22 are minor minerals.